Okay, folks, so the next question we're looking at is 2020 question 4. It was an experiment to determine the resistivity of nichrome wire, in which case the resistance or of a length of wire L was for a uniform diameter was recorded, and they repeated the experiment with a number of different lengths of wire, and they also recorded the diameter of the wire, and they gave us, as you can see, 6 pairs of data for L and R, and they also produce a single value for the diameter of the wire. And typically this experiment was done in previous years with calculations, but we can also do it with a graph, which we will go through in this today. First thing is question 1, name the pieces of apparatus. So it's only asking you to name them to measure your diameter of your wire, the length of your wire, and the resistance of your wire. Now, when we're putting in our answer, it's always good practice to use full sentences when you're doing this. So don't just write A in one word, B in one word, C in one word. You're not really always guaranteed to get it. So in this case, the first thing they've asked us for is what's used to measure the diameter of the wire. So just simply the diameter of the wire is measured with, you have two options here. One is a micrometer, but not every lab's going to have that. So you might also say with a vernier calipers. They also will accept a digital vernier calipers as well. So that's what we have just for part A. For part B, they asked us how do you measure the length of the wire, and simply the length of the wire was measured with a meter stick. There you go. There's your full marks there again. And C, the last thing they asked us for was the resistance of the wire. So again, a full sentence. The resistance of the wire is measured, or was measured, sorry, past tense. They don't really worry about that in the exam, but I just like to have a habit of it. Was measured with an ohm meter. They're not too issue about the spelling, but as per always try to aim to have the most accurate and most precise spelling as you can. Okay, the next question that they had was how did the student ensure that the diameter of the wire was uniform? I'm going to write down two sentences because as good practice, this is what you should do. But the marks are actually awarded for each sentence. So you only have to have one of these two sentences, but you are better off writing in both, I think. And also, it's probably the best way to do the experiment. So a fresh length of wire was cut from a spool of nichrome. That's the kind of when you buy the nichrome wire, and it kind of comes wrapped around that plastic former, and you just basically unravel it to get your nichrome wire from a fresh spool of nichrome. And the reason why you want to use a fresh length of wire to ensure there were no kinks in the wire. So there's unlikely to be, or there's less likely to be damage in the surface of the wire when you use something fresh straight off the spool. No kinks in the wire or on the wire. Now that's enough to give you full marks, but I'm also going to put in the second sentence, which is the other thing, and realistically you should always do both of these. The diameter was measured at multiple points along the wire and an average was calculated. Okay. Now, either of those two bullet points give you the full marks, and it's just just 3 in this case. But again, I think when you see a question like that, you're better off actually writing down both reasons, because it's better practice to make sure that you do cut a fresh length of the nichrome wire from the spool that has been ordered to the lab. And it is better practice to ensure that you take the diameter at multiple points and calculate the average. Okay guys, so the next question asks us to do a graph of R versus L. So this comes back to our formula, and our formula for resistivity and area, length, and resistance is R is equal to rho L divided by A. So when we're looking at this, we're just going to model this into a linear equation to see exactly what we're doing. So I'm going to factorize out the rho and I'm going to factorize out the A. So that gives me resistance is equal to rho over A multiplied by L. If I just kind of put that in brackets there. So again, all I've done is I factorize out the R and the A. Sorry, the rho and the A. So if I model this as y is equal to mx, which would be a straight line graph through the origin, mathematical equation, if I put resistance on my y-axis and I put length on my x-axis, then that means my slope is equal to rho over A. So my slope is equal to rho divided by A. Or in other words, if I want to find my resistivity, that's going to be my area multiplied by my slope. So now I know what I need to do for my graph, and later on I also know what I need to do with my graph in order to turn it into a resistivity. So that's why they want me to find a slope in a later question. First thing I would always do is I would write out my table, and I would write out my table using the units that I'm supposed to be using. So if I go back and look at my original question, they did give me the resistance in ohms, they gave me the length in centimeters. So what I will need to do is I will need to turn all those lengths into meters. So here I'm going to have resistance. Here I'm going to have my length. That's going to be in meters. That's going to be in ohms. Okay. So my values for length are going to be 0.3, 0.4, 0.5, 0.6, 0.7. I'll just have to extend this table a little bit. 0.8, and do I have another one? Oh, so that's as far as it goes. My resistance values will be 0.11, 0.14, 0.17, I think is the next one, yeah, 0.17, 0.21, and my final two values, 0.24, 0.28. Okay, so now what I've done is I've just put my values into the appropriate numbers that they're going to be. My next job is to actually draw my graph. So again, we're going to just switch this to graph paper. In the exam, make sure you ask for graph paper, and when you're doing this, ensure that you use essentially the full size graph when you're doing it. So your graph should pretty much be one A4 page when you do the whole thing. So I'll just start drawing my y-axis. I'll just draw from here. And I'll just move that down the page a little bit. So just move the page down, move down, there we go. And I'll go across as well. Okay, so length will be the easiest one to start off with. So I'm going to go across 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1.0. That's my length. That is in meters. Okay. What I'm going to do is I'm going to go up my x-axis, my y-axis. I'm going to go up and make this here 0.05, 0.1, 0.15, 0.2, 0.25, 0.3. What that will allow me to do is that then each little box, because there's 10 boxes between the 0 and the 0.05, that means everything is 0.005, which will give me nice numbers to work up with when I count. Okay. So first thing I need to do is 0.3 on my length, and that had a resistance of 0.11. So what do? I'm going to go 1/5 away, which is 2 little boxes, and I'll just put a dot, and I'll put my little circle there. The next one was 0.04, 0.4 in the meters, and that had a resistance of 0.14, so I count up 8 little boxes, and that gives me my little point there. The next one was 0.5, and that's 0.17, so that's 4 of the little boxes up from here. Put a little dot, put a circle around it. Next one, 0.6, 0.6, and that's 0.21. So I'm going to go to 0.2, go 2 little boxes, put a dot, put my circle there. I'm going to just maybe fix that, make it a little bit better. There's my dot, there's my circle. So again, as I've always said before, the little dot in the middle is the actual data point, and the circle around it is just to drag my attention to it. The 0.7 meters goes to 0.24, so I go up 8 little boxes, draw a dot, put my circle, and the last one, 0.9, goes to 0.28 ohms, so I'll bring that up, and I go up 6 little boxes, and I put my dot, and I put my circle. So as you can see, we are getting a line that takes the shape of a straight line graph through my origin. So just put down my ruler, start from 0, 0, draw one continuous straight line going through it. As you can see, there's quite a good distribution there, and a lot of the points are actually on the line as well. I do have a distribution where this one point here is a little bit above, this one point here is a little bit below, and everything else is pretty much right on the graph. Just to make sure I have everything there. Again, this is my resistance written in ohms. My lengths are down there in meters, straight line graph through the origin, and a good distribution as well. So that graph there will get you full marks. Okay, folks, so the next question then looked to ask us to find the slope of the line that was given, or not given, but the line that we drew on the graph. So what we need to do is pick 2 points from the line. What I like to do is I like to pick 2 points that are on the line but did not come from any of the data points. So these are the lines I'm going to use here. First one here being 0.1, and that looks like it goes with 0.03. And the second point I'm going to go with here is 0.2, and that looks like it goes with 0.07. Now, as you can see, for the sake of the software, I'm after changing back to the standard little squares instead of the graph grid. So you'll be able to do that a little bit more accurate than I will. But for the sake of this demonstration of how to do the question, this is absolutely fine. So again, to find the slope, standard formula, you do not have to remember it. It's written in your log tables, but you probably have it learned off at this point. Your slope is equal to y2 minus y1 over x2 minus x1. Okay, and you will get marks for writing that down. So just write down your point, 0.1 and 0.03. And my other point is 0.2, and that goes with 0.07. So when I have my 2 points written down, I also make sure to label them, x1, y1, x2, y2. So throw them into our formula. Our slope is equal to 0.07 minus 0.03, that's all divided by 0.2 minus 0.1. Now that gives me a slope, which is equal to 0.04 divided by 0.1. And when I do that on my calculator, that gives me a final value of 0.4. And if I want, I can put a unit on that, although it's not necessarily required for the Leaving Cert exam. But since it is resistance on my y-axis over length on my x-axis, that would be ohms per meter. But all you have to do to get the full marks is the 0.4. I'm just putting that in because it just goes into my head automatically. Right, the next question that they ask us to do is hence calculate the resistivity of the material. So when you see hence, what that means is it wants you to take the answer from the last question, which in this case was our slope, and use it to find the resistivity of our material. So if we go back to when I modeled the equation, I had resistance was equal to my resistivity times my length divided by my area. I then factorize that to get resistance is equal to resistivity over area times L. And since this went on the y-axis, this went on the x-axis, whatever's left is my slope. So my slope is equal to my resistivity divided by my area. My area, because it is a cylindrical shaped wire, my area for the cross section is pi r squared. So that means 0.4 is equal to my resistivity divided by pi r squared. So what I need to do is I need to just go back to the question and look up what the diameter was. The diameter from the data table was 2.05 millimeters. So I'll just take a little bit of space here on the side. And I'll write that in on the side, that my diameter was equal to 2.05 millimeters. Then if I divide that by 2, my radius is equal to 1.025 millimeters. So my radius is equal to 1.025 multiplied by 10 to the minus 3 meters. I now have a value for my radius, which I can put into that formula, and I can now use that to find my overall resistivity. So what I need to do is I need to move the pi and I need to move the r squared. Well, right now there's a pi dividing, so if I multiply this side by pi and I multiply this side by pi, well, that's going to simplify off with that, and I'll have 0.4 pi. I can also multiply by r squared, and I multiply this side by r squared. This disappears with this. So my next line will look like 0.4 times pi times r squared is equal to my resistivity. Then all I need to do is substitute my numbers in. 0.4 pi, I'm going to use the value of 3.14, and r is 1.025 multiplied by 10 to the minus 3 squared is equal to my resistivity. So what I can do is I just need to multiply out all those numbers to get my resistivity. So my resistivity is equal to, and I'll just do all that on the calculator. So that's 0.4 multiplied by 3.14 multiplied by 1.025 by 10 to the minus 3 squared. That gives me a final value of 1.31 multiplied by 10 to the minus 6 ohm meters. Okay, so the last question for question 4, which is part 6, asks us what would happen to the resistance if the diameter of the nichrome wire was doubled, but everything else will remain the same. So just a quick review of circles. So if we have the diameter and we make a circle twice as big, so there we have twice the diameter. But on the same circles, if you have twice the diameter, what that also tells us is that by doubling the diameter, you double the radius. So I'm just going to write 2d leads to 2 times or. So that tells me if I double the diameter, I have doubled my radius. So I'm going to use this idea to work out mathematically just using a little bit of algebra. So here I'm going to use R1 is equal to the resistivity of this wire times the length that I'm choosing divided by area. So area 1. So this is like my first sample of the wire. Now in this case, all these letters have specific values. So I'm writing them as variables, but they all have particular values, which means they're essentially constants. So R1 is the exact resistance of my sample, A1 is the exact area of it, resistivity is the exact resistivity of my sample, and L is the exact length of my particular sample of nichrome. So I can then rewrite this. R1 is equal to rho L over pi R1 squared. Okay, so that means for my first sample, again, it has a particular resistance, has a particular resistivity, has a particular length, and has a particular radius. Now, since I'm after doubling it, that means that R2 is equal to 2 times R1, because I'm just after doubling my radius. So I'm going to write this out now. This is R2, and R2 is the second resistance, which is what the question is asking me about, is equal to, well, it's the same type of wire, so it's the same resistivity. It's the same length of wire, so it's the same length. So I'm just going to write R and L there, and now that's over pi R2 squared. Now what's different between these two things is that the R1 over here, and I'm using R2 over here. And it's the difference in the radius that's going to give me the difference in my resistance. So what I'm going to do is I'm just going to take this and I'm going to move it down into that equation. So that gives me R2 is equal to rho times L over pi 2 times R1 all to be squared. So I'm going to take what's inside those brackets and I'm going to square them. 2 times 2 is 4, and R1 times R1 is R1 squared. This gives me my second resistance is equal to rho L over, now like we said, 2 times 2 is 4, but I'm just going to put my constant at the very start. So that's 4 times pi R1 squared. What I'm going to do is I'm just going to have a look at this, and I'm going to have a look at this, and I'm going to see what's the same. This here is the same as this. This here is the same as this. This here is the same as this. And this here is the same as this. The only thing that's different on the right hand side now is this 4, which is now my denominator. So what that tells me, I just get rid of all these lines. Leave that there. That tells me that R2 is equal to 1 over 4. And what I'm doing is everything else there, the rho, the L, the pi, and the R1 squared, that has a value of R1. So what am I after doing? I'm after substituting all of this, which is the exact same as this here, for that. So that tells me that my second resistance is 1/4 R1. So I'm just going to write that in words. If I double my diameter, and I'll move this up so it's more on screen. If I double my diameter, my resistance will decrease by a factor of 4. And what does that mean in real life? Or in more basic terms? In more basic terms, it means that when you double the resistance, double the diameter, you'll get 1/4 the resistance of your sample of wire.